All right, so let's go ahead and get started. Hi, everyone. Good morning. Thanks for joining our webinar, GIT, Making the Switch Without Sacrificing Productivity. We'll be recording this session, and we'll submit a link to the recording over the next couple of days. So our next webinar is scheduled for April 1st at 11 a.m. Central. Why Wait, Collaborate? Best Practices with the Atlassian Toolset. And that'll be presented by one of our solutions architects, Brian Nye. As you have questions, please be sure to provide them via the questions utility in the GoToWebinar control panel. We'll go ahead and queue them up and answer them towards the end of the session. So on the phone today from Principio Consulting, we have Christopher Pepe, partner here. Chris and his teams engage in highly successful large-scale Git implementations pretty frequently. And this includes his most recent Stash data center implementation for a leading technology company. My name is Shayla Sander, and I'm a business development manager at Principio Consulting. I'll be serving as your moderator. So a little bit of background on us. We've been Atlassian Expert Partners for over 6 years now and are one of 5 Platinum Enterprise experts in the country. Over 99% of our projects are Atlassian related, and we have hundreds of clients across the U.S., ranging in size from 20-person companies to Fortune 20 enterprises spanning many different industries. We help our clients with process-centric technology solutions that facilitate traditional business process management, IT service management based on ITIL, and software development life cycles. In the SDLC space, we're helping our clients transition from waterfall to agile, so whatever widgets you produce, we can help improve the quality and throughput at the lowest cost. We support our clients in all facets of the Atlassian product suite and build methodologies and solutions across the entire product line. This includes solutions architecting and implementing, licensing, upgrades and maintenance, solutions, managed services, hosting, add-on development, and of course, training. And with that, I'm going to go ahead and turn it over to Chris.
Thanks so much, Shayla. All right. So today we're going to talk about switching from whatever centralized version control system you're using today to Git. As Shayla mentioned, this is a thing we see lots and lots of people doing now, and especially large enterprises that are pretty technology forward. They want to make this transition. They don't want it to be overly disruptive to their development processes, and they generally want to take it as an opportunity to kind of retool some other things. So I'm just going to talk through some of the differences between distributed version control systems and centralized version control systems, kind of why you might want to actually think about switching. One of the biggest differences is really going to be around branching, and it doesn't really have as much to do with the decentralized part of the version control system, but it's a very, very important difference between Git and then a lot of the centralized version control systems. Two of the really big pain points that we see in making the transition are around automated builds and continuous integration, continuous delivery. So I just wanted to kind of touch on both of those a little bit more directly. And then finally talk through 3 different cutover methods that we have used. So the actual processes that we use to go from the centralized version control system to the distributed version control system, considering all the tooling and everything they have in place. And hopefully, if I'm not too long-winded, there'll be a little bit of time for questions. So as Shayla mentioned, please queue them up in the questions box in the GoToWebinar dialog there, and we'll address those at the end. So first up is a little bit about what a distributed version control system is and the trends that we're really seeing with it. The biggest difference in the model, there's actually even an earlier generation of version control systems or 2 before centralized version control systems, but that's really what the core focus of most businesses has been for the last at least 10, 20 years. I've been centralized version control systems. There's a centralized server that sits somewhere. All of the developers check out a working copy, work on their changes, and then check those changes back into the centralized server. It had a lot of advantages over the previous generation, which was based on all local access and didn't involve any computer networking. So this has opened up the ability to collaborate with other developers, the ability to implement and enforce business process with commit hooks and things like that. And also started really getting us thinking about how we build and deploy our software. But over the last decades or so, a number of problems have emerged as well from using centralized version control systems. One of the biggest ones is that we want to do some of our development work in isolation. So we'd want to create branches and do that work, and then merge those branches back into some mainline. That proved to be very problematic, especially with Subversion. So a lot of companies abandon that entirely and just work directly on the trunk. So everybody's committing back to the exact same trunk, which is also where you're going to release from. Even in that scenario, you still have the problem of getting merge conflicts, and when a merge conflict occurs, anything that feeds off of that central server has now stopped. So all of the developers are unable to update or push any of their changes or commit any of their changes back into the version control system. All of the builds that feed off of that repository are going to break because that merge conflict is going to throw syntax errors and not allow the code to compile. So now the developers, which are the most expensive human resource, and then the build tools are all broken and stalled until that merge conflict gets fixed. That's probably one of the really biggest pain points. And to solve that problem in Subversion and centralized version control systems, we've developed a number of processes to try to mitigate the risks of getting those, and when a merge conflict or some other problem does occur, to minimize the size of it so it's a little easier to undo those changes. So we've developed a lot of processes to work around the problems that we have. Now, Git is the only distributed version control system we're going to talk about today, but there are a number of other ones. Mercurial is also very popular. Git is very clearly the front runner in the whole distributed version control system world, and it's really the one that we focus most of our time on. So it's done two major things. First, it has completely decentralized the way that it works. So every single copy of the repository, as opposed to checking out a working copy, you actually have a fully cloned, fully working mirror of the centralized repository, if you want to think of it that way. So every copy of the repository is fully functional, and you can interact with it and set up whatever workflow you want to interact with that particular repository. Then changes can flow between all of the different repositories. So that's one really big difference that opens up a lot of interesting workflow opportunities. The other big thing, though, is that Git stopped and took a look at what does modern software development look like today. What should that model actually be? And it came up with technological solutions for a lot of the problems that we were having in centralized version control systems. So the way that it thinks about your code is very fundamentally different from the way that, say, Subversion thinks about your code. The way that it handles branching is entirely different. And the way that it handles merging is entirely different. Because of that, it's very easy to create a branch in Git, and it's very easy to merge that branch back into some other branch. And that's allowed us to build these much more complex branching strategies, and has opened up a lot of really interesting workflows for us. It's really one of the major reasons that people are starting to move towards it, is these new design patterns that we can use that promote quality, that promote code review, that promote all the best practices that we know we're supposed to do, but don't necessarily fit seamlessly into our centralized version control system. They fit very, very elegantly into Git, especially if you use this kind of de facto standard that's emerged called Git flow, which is really just a branching strategy that we'll talk about a little later. So as I mentioned with Git, branching is really cheap and merging works. When Subversion came out with branching, they said, branches are really cheap, branch away, branch to your heart's content. And we started branching to our heart's content. And then we started merging, and that's really where the problems came in, and it became very, very painful. So like I said, a lot of teams abandoned merging entirely. That was what we did. Other teams used branches and then started to develop philosophies around, fail fast and integration strategies to try to minimize the impact of the problems that merging branches was causing. With Git, we actually just don't really worry about that. You're actually merging constantly, just all the time merging in Git, and you don't even know that you're doing it most of the time. And when you know that you're doing it, it just works, and you don't really have to think about it all that much. So that's allowed us really to start moving a lot of our development off into branches, and then that's opened up a whole world of traceability for us that I'll try to touch on as well. Everything is local. This is really the distributed part of the DVCS. Excuse me. With a centralized version control system, we have our Subversion server, That's where the repository lives. We can check that out and work on it. We push those changes back. We still have a relatively similar model today, at least in the corporate world. If you're working on the Linux kernel, that's a much more kind of distributed project, and it has a different set of rules for how it actually works. In the typical kind of corporate environment, you're still going to have a product like Atlassian Stash as your Git repository management. And the repository that's in Stash is the golden copy. That's the one that all your build tools are going to feed off of. That's the one that you deploy from. That is the authoritative source of truth for what that repository is supposed to be. But as a developer, when I want to work on that, I would actually go and clone that repository. Now I have a fully functional, fully working clone on my workstation. We can also set up mirrors in a number of other places. Maybe we have a Bitbucket account as well, and we mirror all of our changes up there, or just some of our changes up there, so that we can publish them out to the world. We have full control over what's going to be exposed in our Bitbucket repository versus what's in our Stash repository. So maybe we only push our master branch up to Bitbucket. We don't show any of our feature branches or anything like that. So we have that control to have multiple sources of truth for where this information is going to live. If we have third-party contractors or other less trusted resources that are kind of outside of our corporate firewall or our corporate trust bubble, we can set up our repositories to have different sets of rules. So if we want to work in a single repository, we can apply permissions to all the different branches that we have, so that as a contractor, maybe you can only create a feature branch. Or you can only work in your local repository, and then you have to push those changes up through some other set of repositories. The other advantage of having everything be local is that if I'm offline, I can still work. I can still be checking code out, checking it in, keeping it in the repository, as well as having everything be really, really fast. I can choose to work in a different way locally, and then just make sure that I'm pushing the correct branches back up to the main repository. We also have this idea of a staging area, which is kind of like an intermediate place to stage files before we actually commit them. Because our commits are starting to mean different things, and because from a traceability standpoint, we really care about what's going into an individual commit, we can now use this staging area. If we worked on a couple of different things at once, we can take the staging area, use that to stage particular files, and then commit them off as one cohesive and unique change. So the ability to use the staging area has opened up a lot of new possibilities for us as well, and has kind of changed the way that we think about interacting with Git. Now, your mother always told you that just because all the other kids were doing it was no reason to jump off of a bridge, but this is actually a case where there are good, solid reasons for doing it, and a lot of really tech-forward, smart companies are making this change for a particular reason. So certainly don't do it because all of the cool kids are doing it, but Git is becoming the new standard, the new best practice for a reason. So that's something at least to think about. This graph's a little bit out of date. It ends in 2013, but you would just see more of the same if we had more data here. People are moving away from centralized version control systems to decentralized version control systems pretty quickly. Some for the distributed nature of DVCS, others for the new technological solutions that have been built into those. As a quick aside, some of the centralized version control systems are actually now starting to take ideas from DVCS and pull them in. It's kind of a case where they're more trying to play catch up than anything else. From the ground up, Git is thinking about your code in a fundamentally different way, and it's pretty difficult to take some of the concepts that are built into Git and apply them back to the way that centralized version control systems work. Down along the bottom, Mercurial is included in this, and it is a distributed system as well. But otherwise, there's TFS, Perforce, and then the red line is Subversion. Subversion is by far the most popular version control system that was out there before Git came along. And you can see that since 2006 or so, the blue curve is Git. Git has been gaining popularity at an exponential rate. It is continuing to bring in more and more teams. We've actually had Well, now what we see is the majority of companies that are starting out now, the majority of startups are starting with Git. They're not starting with something else. That's just the starting point. And certainly today, I think for most of your companies, if you had a bunch of code and you wanted to revision control it and you went out there and said, well, what should we use for version control? You would probably pick Git. I think a lot of the folks that are still with a centralized version control system are there because they have a lot of history with it and they have a lot of tooling built into it. But even with that, it's not an impossible task to retool and to move things over so you can start to take advantage of these better design patterns and get higher quality and better work out of your developers. This is an innovation versus adoption curve. You really can actually apply this to any technology. So really, we're going to talk about it with Git, but I'm going to start with say Subversion or Perforce. Both of those are systems that are really probably in that third section there. That are the folks that are going to stay with them are really in that I need safety. I know that this has worked successfully for us for the last 10 years. I know that's not going to change, so I want to continue down that path. I don't want to take on all of this new change. But it's really in that kind of later phase of its life cycle. Like I said, Perforce has pulled in this concept, they call it streams, and it's really branching that has taken some of the concepts out of Git and tried to backport them into Perforce. It doesn't really work quite as elegantly. You still have the challenge that branches in Perforce, you kind of need a Perforce expert to really create them and manage them. As a developer, I'm not going to go create a branch, do a little bit of work, merge that and destroy the branch, and do that 3 times a day. That's just probably not going to happen. So they're really in a state where they're not really innovating all that much anymore. Their innovation is dropping off. Git has already gotten well past its early adopter phase, and it's really kind of in that sweet spot on the upward curve of its adoption. If anything, it's probably kind of down near the bottom of it. I'd say it's still got a lot of legs in terms of adoption before it really hits its peak as well. In 5 years, I don't know if Git will still be the king. But certainly folks will be moving towards Git for the next 5 years, 10 years probably even. Hopefully by 10 years out, we have the next greatest thing in version control in a much, much better way to think about our software development practices and much better processes and best practices. But for today, this is really, this is where everything is going, and this is where all the best practices are evolving to. So I can't talk enough about branches. Branches is probably my favorite thing in Git. I was a very stubborn convert to DBCS. I didn't want to make the change. When I did, I changed to Mercurial because it was a lot more like Subversion, so it's a lot more comfortable in what I was used to working with. But eventually I switched over to Git. We started using Git in all of our teams, and we started off using Git just like we used Subversion. So because my background was in developing directly off trunk, that was what we did. But before that, we had tried a number of different things. So we would have our own branch. Most of the places that I worked, we had our own developer branch. So I had a Chris Pepe branch, and I did all my work on that. It's still really popular. What we see today, though, is there'll be a team branch or a sprint branch. The branch is pegged to some kind of a concept. So for a sprint, at least it's an iterative thing. You're going to have a branch for some period of time, merge it, and then create a new branch later on. For the individual developer or team branch, these are just persisting branches that live forever, and we just regularly integrate back up into our main line from them. So in my world, where we just develop directly on trunk, I wouldn't have this master branch, the light blue one. We just had the bottom one, and we all committed directly to it. That causes a number of problems, especially when you have multiple developers working on the same project. It becomes very difficult to figure out what changes did I make to implement my feature versus what changes did you make around that same time, because our commits all get interleaved together. You have to, with a very fine-tooth comb, go and pick out individual commits to figure out what were the specific changes that I made and how did they impact our code base. The other really big problem with having either a developer team sprint branch or all developing on trunk is this scenario I've laid out here. So we have purple, which is some new feature that we're creating. We have green, which is a bug fix. So these are two things that came up at different points in time. So I get assigned this new feature, maybe to make an animated menu for our website. So when you hover over a link, it drops down a menu. So I go off and I start working on that, and I make a couple of commits against it. And maybe at this point, I've kind of stubbed out the concept of it. I've got it so that when you hover over the element, a menu drops down, but I just have a bunch of dummy divs in there representing what a menu would look like. I don't have our actual menu in it. Around that same time, a really important bug gets discovered that needs to get fixed, and that gets assigned to me. So I go off and still on my developer branch, I fix that bug. I go and figure out what the problem is, figure out what we need to do to fix it. I make a couple of commits, and I fix that bug. So now I'm in a situation where I have a bunch of work that I've done on this new menu for our website, but it's not done, so I can't ship it. And I've completed all of the work on this bug fix. So I can either go back and try to stub out and comment out all of the code that I made for changing our menu so I don't impact our actual menu that works now, and then merge this change up so I can ship that bug fix. Or what I can do is just sit on that bug fix and go and continue working on my menu until that's done, and then merge that up. So in either case, I'm either taking a really big risk in trying to stub out code and comment out code and have this kind of messy situation so I can ship this bug fix earlier, or I have to sit on that bug fix and wait and not ship it until later. Neither of those is really a very fun situation to be in, and neither of those really promotes higher quality in our code base. Because branching is much more effective and much easier to do and much less painful, we do it really regularly, and we don't really think much about creating branches. So now what we would do is change the idea that we're tracking with a branch from being a developer or a team or a sprint. We move it to being the feature itself. So we call them feature branches, and they generally represent new features and bug fixes. So in the Agile world, they represent stories and bug fixes for the most part. These are typically feature branches are typically going to be relatively short-lived, so 1 to 3 days, although I've created feature branches that only live for a couple of hours. Still, our convention is no matter what you're doing, you always do work on a feature branch and then merge it back into our main line. This particular branching strategy is what's called feature branching. It is a great first step to go into feature branching. There's actually a much better version of it called Git flow. We're not going to talk about it today because this isn't as much Git theory, but there is a lot of retraining developers and rethinking about how you address your software development problem that goes into making the switch to Git. Because if you don't change your processes, then you're not getting any advantage out of changing to Git. So here in feature branching, in the exact same scenario, I'm working on the animated menu. I've got it kind of working, but not really ready for production. And then this bug comes up that needs to get fixed, which gets assigned to me. So I go and I create a different branch, and then I go and fix that bug. Now I can merge that bug back up into master. Now that bug is shipped. It's now being pulled into all the other developers' workspace. It's being tested through our automated integration testing, through unit tests, as well as whatever work QA is doing on the master branch, because they're continually testing as well. So now my bug fix is going to get tested a bunch of times before it actually gets shipped. And I didn't have to worry about sprinkling in any of my animated menu code that wasn't really done and ready to ship yet. The next step from this, because you can have integration errors in your master branch, would be to instead feature branch off of a branch called development, merge into that, and then there's a couple of other steps that you would take for Git flow. There's a number of advantages to that as well. You can tie it to your different testing environments. So every time we merge into our development branch, we can automatically deploy out to a integration testing environment. When we merge into a release branch, we can deploy it to a QA UAT environment, and when we merge into master, we can deploy it out into production if we want to. But you can take advantage of a lot of those things using any version control system, but the merging between those branches is going to be a lot more painful than it is with Git. So that I wanted to talk about automation just a little bit. In the old days, 10 years ago or so, a lot of our work was done locally. We built all of our packages locally. We built the final product and shipped it, which was usually emailing it off or copying it up to some server somewhere. We did all that work by hand, and it was really cumbersome, and it was a lot of work. And 5-10 years ago, a lot of the kind of front leading edge companies were starting to think, this is ridiculous that we're sitting here banging away at this keyboard when we could have a bunch of robots doing it. I could be sitting back drinking a cup of coffee. I don't need to do all this work. So we started writing scripts. So you probably have shell scripts or Perl scripts or Python scripts laying around that run on some server somewhere, which feed off of your version control system, which go and actually run a build, create your package. We've even seen people have developed their own packaging, rather than using like a tarball or a jar file or something like that. They have their own packaging format, which has their own metadata in it, as well as all of their own artifacts. And that package is then able to be deployed through a deploy system that they wrote in Perl as well. And because it was written in Perl 10 years ago, nobody has any idea what it does, not even the people that wrote it. So this is a really common scenario. It's either no automation at all, or if you have automation, it's some evolution of technologies throughout the years. As those best practices were being formed, people were trying a lot of different things. The best ideas from all the different things that we try to become our best practices, but everything that you tried is still laying around as well. It's just not in today's set of best practices. That's usually where the challenge is, and usually when companies are going to switch to Git, they're looking at modifying their development process to have their developers work in an entirely different way. But they're also using it as a chance to retool and leave behind all of that cruft from the old system. So some folks like to take those scripts and just stuff them into Bamboo, and now you have Bamboo acting basically as a scheduler. That can work as long as you do it well, but in a lot of cases, it's usually better to try to figure out what is our actual build process. Do we want to maintain that process? And if yes, what are we actually doing? If no, how could we be doing this better? And think about what that new build process should look like. This is really going to drive towards continuous integration, continuous delivery, and much like Agile, every company that we go to does CI and CD, and everybody does it in an entirely different way. So what it means to you is going to be different than what it means to everybody else that's on this webinar. But I think that's just fine. There's a lot of advantages that you can take out of it, whether or not you're strictly adhering to the philosophy that somebody came up with for where this idea came from. Some of the advantages that you're going to get by moving to Git is that all of these new feature branches that you're going to be creating are automatically going to be picked up by Bamboo. So the build plan that you use to actually build your master artifact that you ship, you want to apply that same build to all of your feature branches. Because you're writing unit tests, which is another best practice that I assume you're doing, then I can see you all smirking. Because you're writing unit tests, you're automatically testing all of your code. So now when someone's working off on a feature branch and modifying the model of your data, if they do it in such a way that now a test fails, then that build is going to fail. And now we've failed on a feature branch, so we haven't stopped any other development work. We haven't blocked anybody else. We haven't broken any build tools. We just have a broken feature branch build, which is not a big deal. Maybe the test needs to be updated because we're changing the way that we're structuring our data model, or maybe the code itself was modified in a way it shouldn't be. Either way, we're getting feedback from the system without blocking anybody else, and Bamboo is automatically picking that up. Now, a little freebie for all of you that are using Subversion is that Bamboo will also pick up new branches created in Subversion and automatically apply builds to those as well. You're still working in the limitations of branching within Subversion, but you have the ability to at least run CI builds against it within Bamboo. We can then start to use these build statuses as well as part of our software development process. I didn't really talk about it much. I just said we merge things. When we take a feature branch, we merge it back into our master branch. But really the best practice there, and what Git has opened up to us, is this idea of pull requests. I know you're all doing a code review on every code change you make as well. So that's great, and I'm really glad to hear it. The challenge that we generally have, especially in that trunk-driven development, is we have to commit to trunk, and we now have code that's out there for everybody to use before we actually reviewed it. Or we have to do a patch review, in which case we don't have that code in our revision control system, and really neither of those are places that we want to be either. By creating a feature branch and doing all of our work there, we're able to keep all of our code changes in the version control system. We can very, very easily take the difference between two branches to see what we've actually changed. And then when we want to go and merge that, we create what's called a pull request. So we create a pull request either between two forked repositories or between two branches in the same repository. In either case, the result is the same. The difference between those two entities, those two branches, is going to be taken and dumped into a code review. Then we can go through line by line, do our code review, comment on it, have discussion, have the developer make updates and put those changes back in. We can then feed off of things like our CI builds to say we have rules that are strictly enforced. At least 10% of the team or 20% of the team has to approve this change before you're allowed to merge it, and it needs to have a successful build before you're allowed to merge it as well. So we can enforce those with pull requests, or we can just have a convention as a team. But in either case, we can ensure that we're doing code reviews, have it be a very, very natural part of our development process, because we create our feature branch, we want to merge it back into our master branch. Rather than use the merge command, we just create a pull request. So now we have this very natural, easy, non-disruptive way to do code review, and then finally go and do that final merge to move our code back up. Now, if you look at these branch names, you'll see that they all have Jira ticket keys in their name as well. We're actually using the integration between Jira and Stash, which you can also have between Jira and Bitbucket and Jira and GitHub, to, from a Jira issue, create a branch. So now, because we are encapsulating stories and bugs, that's what we're using a feature branch to encapsulate. We have a Jira issue that represents every body of work that we're going to do. We never do any development work without a Jira issue being created first, and we rarely create Jira issues without product requirements being created first. So now we have traceability from the initial product requirement and all of the discussions and wireframing that we did around that, to the Jira issue and where it is in its life cycle, to the code that was changed, because it's all encapsulated in that feature branch. We can always go back and look at what was the contents of this feature branch, what did we change for this specific feature or bug that we fixed. And then we also have all the build history that's associated to that, and then code review. So even if you're doing code review in Crucible, or if you're using pull requests within Stash, all that information is getting pulled back into the Jira issue. Even beyond that, if you're using deployments within Bamboo, so if this particular if a particular issue was included in a build that got shipped in version 1.2, we can very easily see all the Jira issues that were associated with that particular deployment, and the specific environment that it was deployed to is going to be reflected back in all of those Jira issues as well. So we have this kind of unparalleled ability to track down changes that are being made, figure out exactly how they got into the work, into the pipeline, what actually got changed in them, where they got deployed to, what its entire life cycle was. Really, all of that is an artifact of the fact of using feature branches and tying those feature branches back to a specific Jira issue. That's what enables us to get this really deep level of traceability. But let's talk about the actual cutover methods that we use as well. So far up to this point, what we have largely talked about is kind of the people side, why you would want to change to Git, how you will effectively use Git. Probably the single most important part of your transition from any version control system to Git is going to be training your, I say developers, but in that I'm including all of your build and deploy staff. So release engineering, QA, anyone else that's doing any testing, all the different development teams, all of those folks, everyone that's interacting with the version control system. Training them up to understand how Git thinks about the world, to change the way that they are thinking about their products, because again, this really does need to go all the way back to the way that you are creating your initial product requirements. You don't have to make all of this change on day one, but eventually you're going to want to get to the point where you are fully utilizing all the power of Git, and that's going to mean thinking about your products in different ways, road mapping them in a different way, scoping out new product requirements, decomposing things down into story-sized chunks that can be completed in a 1 to 3 day time cycle. That's really kind of the optimal time frame that's really emerged for folks that are using Git. Branches that are shorter than that aren't quite as worth the overhead, although it's really not that. That's kind of the lesser problem. Branches that are longer than that, you're starting to get kind of too many changes bundled up, and then merging starts to become harder, and that will ripple through the rest of your environment. But changing your product requirements, changing the way you're actually tracking your information in Jira, and then creating feature branches, developing on those feature branches, going through code review, having all of your automated tools built in. That's really going to enable a much more frictionless, smooth development process that promotes quality. To get to that point, though, you need to actually take your code base today and move it into Stash or into a Git repository. So the 3 different processes that we have used that we like, we've come up with names for them, and if you have better names, we're always open to suggestion. The atomic cutover is pretty straightforward. This is it's the most recommended. It's kind of the easiest to do. It's technologically the simplest, and it requires the least amount of risk and kind of technical coordination. It's the most disruptive way to do a migration, though. But the process is pretty straightforward. You have your developers, and they are committing to, I'm just going to use Subversion as the example for all of these, but they're committing to your version control system. So you declare some sort of a maintenance window. So Friday, 5 p.m., we're going to do this migration. So Friday at 4:59, all the developers need to have committed all of their code into Subversion. Then at that point, we take that Subversion repository, we turn it into a Git repository, and we push it into Stash. Then when everybody comes in on Monday, they clone the same repository from Stash, they delete their old Subversion repository because they're not going to use it anymore, and then they just start developing in Stash. So if you can time it well, and if you aren't a 24/7 shop, this works especially well for small teams where it's not really as disruptive, small repositories, things like that. It works especially well when there's not a lot of dependencies into your old way of doing things as well. If you don't have to do a lot of work to get the code that's now going to be tracked in Stash to build and be deployed effectively, then this is a really effective approach. If you do have a lot of dependencies on your old build system, if you can take a lot of time to migrate all of those things over and then just do the atomic cutover in the end, it still works really well. This is how we did the last big migration that we did. We did it atomically, even though it was a 2 gigabyte repository with hundreds of developers on it. We still did it this way. We just did a lot of work in the beginning to do all the retooling up front. If you want a slightly less disruptive process, one that we presented at Summit last year, lovingly calling not the Atlassian. The next one that we're going to do is called the Atlassian. So this one's not the Atlassian. And it's kind of the opposite direction of how Atlassian did their Subversion to Git migration. This particular method works really well when you have really heavy legacy dependencies. So your build and test and deploy systems probably were homegrown and are very intimately tied into your version control system. They're looking for very specific file paths in very specific places. There's a lot of things that are hard-coded into these scripts that are pointing specifically at your old version control system, and they're making assumptions about the data structure, the structure of the file system that they're going to be checking out. That's going to be changing when you switch to Git, because again, if you're retooling, you're probably going to rethink the way that your source code is organized, and you're probably going to end up creating multiple repositories or restructuring the way your repository is laid out. So if your legacy build, test, and deploy tools are really heavily tied into that file structure that you have now, it can make it very difficult to do all that retooling. In this situation, it's typically you want to move to Git to get the advantages for your developers to start getting that higher quality output, but you don't necessarily want to have to wait until you have retooled everything. So in this scenario, the very first thing that we do is we take your repository, your Subversion repository, turn it into a Git repository and stuff it into Stash. And then we set up mirroring so that every time you commit into Git, that commit is mirrored over to Subversion. Now at that point, you can move your developers over and they can start developing in Git. And you can have your mirroring set up so that maybe only your master branch in Git pushes to the trunk in Subversion. And then that still effectively mimics the way that your old production build worked. So now people can go off and feature branch to their heart's content. They can merge into the development branch. You can go through all the code review processes that you want. And then when you finally go and merge to that master branch, that will get mirrored over to Subversion. Your old build and test systems are already still sitting over, they're still running off of Subversion, and you're going to get your actual production artifacts out of that. Meanwhile, while all of that is happening and the developers are off and running and doing their thing, your release engineering team is going in and retooling so that now you're building off of Git as well. So you still have all your production stuff coming out of Subversion, but you're also producing all of those test results and all of those builds directly from your Git repository. And the only reason you're doing that is so you can compare the stuff that's coming out of your Git builds with stuff that's coming out of your Subversion builds. And whatever your success criteria is, once you feel like the test results and the artifacts that are being built from your Git builds are the same as the ones from your Subversion builds, then you can simply cut that mirroring link between Git and Subversion and start deploying from your Git builds instead of your Subversion builds. All the while, your development teams were still off and running, getting to take advantage of Git, but they didn't necessarily have to worry about the release and testing end of it. Obviously, there's still a lot of coordination that you're going to have to do between development, the QA team and the release engineering teams. But that is a pretty low amount of friction, and it gives you a lot more time, as much time as you need to get all of your tooling readjusted to point at Git. So the last method is what we call the Atlassian. Atlassian has a great set of blog posts on how they did their Subversion to Git migration, and this was basically their process. So for them, what was very important was to maintain the velocity and to not disrupt the development teams. The development teams had a really good cadence. They had very good processes around how they were using Subversion, and they didn't have a lot of Git training. They didn't have, at least as a team, at least their team dynamics weren't structured to work effectively in Git. They were structured to work effectively in Subversion. So for them, they have developers continue to work in Subversion through the entire process. Again, you have Bamboo producing all of your production artifacts as well as running all of your automated testing and deploying. Still do the same thing. You take your repositories, you turn them into Git repositories and stuff them into Stash, and then you set up mirroring. So every time somebody commits into Subversion, that gets mirrored over to Stash. All of the production builds are still building off of Subversion for the entire time that this process is taking place, but now you copy all of that infrastructure and you start to retool it so that it's able to build off of Git instead of building off of Subversion. This becomes a lot trickier if you're trying to manipulate and change the way your repositories are built, but you can still do it, and if not, you can always fall back to the atomic cutover when you're ready to do the actual production cutover. But here, all of your commits are mirroring over to Git, and again, you're just readjusting your all of your tooling so that the tests and the built artifacts that are being spit out of Git are getting closer and closer to those ones that are coming out of Subversion. And once your success criteria has been met and you have the same in both systems, you do a ton of training with your developers, probably in between sprints. Maybe you even, if you feel like you can take the break, you even take a little bit of time away from development, or you cut everybody's velocity in half to give them time to start ramping up on Git. But at that point, once all of your builds are coming out of Git successfully, you cut that mirroring link from Subversion to Git. You have everybody move over to Git and clone that repository and get back to work. In all of these cases, when you switch over to Git at the very beginning, the easiest thing to do is do exactly what you're doing today. Just do it in Git. That way people get used to pushing and pulling, working with a distributed version control system, and some of those kind of nuances of the new sets of tools that they're going to be using. Then you add in feature branching. And then finally, you go to a full-blown Git flow workflow where they have a number of different branches, and you have all of this increasing quality as you promote through the different branches. So just to recap, we went through kind of the differences between centralized version control systems and distributed version control systems. The other big takeaway from that is that DVCS, being the next generation of version control systems, has taken all the stuff that we have learned with the internet over the last 20 years and added in a lot of social features. I know we didn't talk a ton about them, but there's a lot of social features within it that really promote better and more inclusive coding, even when you have untrusted parties like third-party contractors or totally anonymous people that are on the internet, as is the case with the Linux kernel. Also took a look at the problems that we've had with centralized version control systems, and rather than rely on the processes that we've built to mitigate those problems, has rethought about how we build code and built those new technologies into the version control system itself. The biggest thing that it's opened up to us is branching strategies, and that has rippling effects through our entire build and deployment infrastructure that gives us much better traceability, much better visibility, and higher quality without really having to do anything. It reduces the amount of friction in a developer's day-to-day life. Around automated builds and CI, if you're not doing it now, start doing it immediately. Also start doing code reviews. If you have a bunch of tooling in place, that's going to be one of the technologically most difficult parts of the transition. If you have questions about it, or if you want help with it, please feel free to reach out to us. We've done it a number of times now, and we've seen a lot of different stumbling blocks. So we have a pretty good idea of how to approach that problem. I'd also love to hear, if you've already cut over to Git, if you used a different method, I'd love to hear what you did, especially if it was a technically complex or novel way of doing it. But the three that I presented are three that have worked really well for us. And now it's time for questions. I don't show any questions on my side. Shayla, did you get any come through to you?
Let's see. I do have one. So if I wanted to switch to Git, what does the timeline typically look like? Is there anything I should be aware of in making the switch?
Yeah, so I mean, definitely from the awareness perspective, the build, test, and deploy infrastructure that you have in place now needs to be changed. That's the technically most difficult piece. The other side of that is the human side. So having your developers understand the way Git thinks about the world and start to think about these new development patterns. So the training that they're going to need to go through to be exposed to all of that. Those are the two most difficult pieces of actually doing the migration. Timeline-wise, it really depends on how big your code base is, how many repositories you have. If your development team has any familiarity with Git, I mean, one thing that you'll notice is that if you have younger developers that have been, if you have younger developers that are within the first maybe 4 years of their career or so, it's very likely that they were using Git in college, either for their own side projects or for things that they were doing in class. For folks that are farther along in their career, it's still quite likely that some of them are working on side projects or have their own software development projects that they do outside of work, and they're probably using Git to manage that. So one of the things you'll probably discover if you have a big enough developer base is that you actually have a lot of Git knowledge already internally. That's one of the biggest things that helps people transition, is that if there's someone on your development team that knows Git already, that gives you somebody to go to talk to, as opposed to having to go to the stash administrator or the migration team. So depending on how much internal knowledge you already have, and depending on how complex your environment is, that's really going to drive how long it's going to take. But it could be, we've done cutovers for teams that were prepared. Once we get access and all that stuff, it can take 10 minutes. I think the longest project that we have done was about 8 weeks or so to do like a big enterprise migration, and that's really more just the retooling and migration piece. The training is going to continue to go on for quite a while after that. But it can be very, very fast and very painless, or it can take quite a bit of time. You just want to make sure that you think through all of the pieces before you actually do it.
Okay, thanks. So the next question is, I've heard conflicting stories about Git and binary files. Some articles claim that Git is terrible for managing binaries, and others say that it handles it just fine. What's your experience?
Yeah, so my experience is actually both of those things. I have found that Git is terrible at managing binary files, and that it's great at it. There's a feature that was introduced pretty recently. I'm trying to remember if it was into Stash or into Git. I think it was actually into Stash. But with Git, you can declare whatever diff tool you want. So it really is going to come down to depending on what type of binary file it is. If there's a good tool out there that can diff the two types of files, like for instance for Word documents, they're binary files, but there are tools out there that can convert Word documents into readable text, which then is very easy to get a kind of a side-by-side diff. One time I saw this really, really novel image. So for PNGs, JPEGs, for any kind of image, it was a diff tool that instead of doing like a side-by-side diff, it laid the two images on top of each other, and then you had a slider bar that you could drag back and forth. And by kind of dragging it back and forth, you could see where the two different pictures differed and how they changed. So I think as far as being able to diff the two files, it's going to depend on what the type of file is, but there are really good and easy ways to get that diff in there. Usually with binary files, merging is going to be a particular challenge, and I think that's still probably a challenge. If you're a video game company or if you have large binary artifacts, Perforce is probably the version control system for you. If you don't have lots and lots of gigabytes of really big binary files, especially if most of your files are text and code, then Git works just fine. It's one of those that kind of depends on your particular scenario. I definitely understand why people complain about Git handling binary files, and it's certainly not its kind of core competency or its core goal in life is to be the best binary file manager. You can certainly make it work in a lot of scenarios, though. And again, it's really finding that diff tool to be able to diff the two versions of your binary file.
Great. Thanks, Chris.
If it wasn't clear, you find that diff tool, and then you tell Git to use that diff tool, and then it will just use that tool to diff the two files. Sorry, go ahead, Shayla.
Sorry. So next one, will we be getting a copy of the presentation? Yes, that'll be sent out in a few days. Next question, have you ever encountered SVN externals during your migration to Git efforts?
Actually, the majority of the big migrations that we've done haven't been from Subversion, so I haven't run into a lot of interesting Subversion scenarios. Usually, when we're doing Subversion migrations, they're relatively small and relatively uncomplex, and we're able just to convert the repository quickly. That being said, we've run into a lot of different technical challenges and have been able to help our clients work through those.
Okay, so next question. When doing an atomic cutover, do we need to make sure all code is checked in on the Friday before the cutover? If that's not possible, how do you manage the transition when SVN working directories after the cutover?
Yeah, so that's gonna you're not doing an atomic cutover at that state, and you're kind of doing more of the Atlassian. So if you're going to have code sitting in working directories that you want to be able to get over to Git, you're going to have to take your Subversion repository and set up mirroring so that when people do go and finally commit those things out of their working directories, that code will get mirrored over into the Git repository. And if you're going to take that approach, then branching and all of those things need to be taken into consideration. Do we have any more questions?
Oh, sorry, I was on mute. The next question is it possible to have another session arranged where we can go through some Git features through a demo? Yeah, we can absolutely do that. You can either reach out to me for a demo, or we can see about adding it to the agenda for, I think around a June or July timeframe is the next time we have an open webinar that isn't scheduled. Let's see, one last one. How does Git handle files that need to be shared across projects?
So one of the changes, I said probably 100 times that Git thinks about your code in a fundamentally different way than centralized version control systems did. The biggest difference is that Git thinks of the entire file system that makes up your project. So, the source directory and the resources directory, whatever all the file structure is, it thinks of all of that as a single file system as the thing that it cares about. So every time you commit to it, what it's doing is actually taking a snapshot of that entire file system. Now, obviously, it's using diff tools and things to only store the patches and saving up file space and all that. But every single commit, rather than being a change set of these 5 files changed, every single commit is a snapshot of that entire file system. So merging between branches and things like that is actually merging those 2 different file systems together. So what that means is, from a permissions perspective, all of your permissions are applied to the entire repository itself, as opposed to the individual file level. So I know, especially with Perforce, what people like to do is say, this part of the depot tree you have permission to, this other part you don't have permission to. That's not the way that it works with Git. Your entire repository is what you get access to. If you have access to the repository, you have access to all of the files that are in there. No, that's not directly what your question was. So if there are specific files that need to be shared across multiple different projects, what you have to start thinking about is, how do we structure our repositories? So the biggest repository structuring question revolves around permissioning usually, but in your case, it's going to revolve around access to those specific files. So if you have like a contrib directory or something like that, or or other dependencies on other products that you build, things like that, you want to structure your repositories so that everything that is versioned together and built together kind of sits in one repository. So those shared files that need to be in a bunch of different places, one thing you might consider doing is making them their own repository. And then you can use either submodule or subtree to include those into the source code view, so it looks like they're in that Git repository even though they're actually being managed separately. It's going to come down a little bit to if those files need to be versioned differently or just shared across multiple repositories. But the shorter version of my long-winded answer is you're probably going to restructure your code so that those shared files are either in their own repository, or if what you actually need is them to be built and then just be kind of linked at runtime or something like that, then you can build them and put them into an artifact management system like Nexus or Archiva, or if it's not a Java project, into an appropriate system so that when the build happens, those artifacts can be included. Alternatively, if you only need them to be there kind of at build time, you can check out multiple repositories in a Bamboo build plan. So it always is going to come back to, it depends on what you're actually trying to accomplish and what your code looks like and all that stuff. But you're most likely going to reorganize your code into multiple repositories so that you have the ability to share that same code across multiple projects. And I think you said that was the last question, Shayla?
Yeah, that is our last question. So thank you everyone for joining. Our next webinar again is going to be April 1st at 11 a.m. Central, and that's going to be why Collaborate, Best Collaborative Practices with the Atlassian Toolset. If you have any additional questions, feel free to send them our way at contact@precipio.com. Thanks a lot and have a great day.